Today we're going to be solving systems of equations again, except this time we're going to be doing this with three variables. So we are used to looking at x and y together, but now let's add a z in there. So this is going to bring us from 2 dimensions into 3 dimensions. Your x is still going to be left and right. Your y is still going to be up and down, but now we're giving the graph depth. We're giving it z, which if you think of yourself standing in one spot and you are at the origin of your own graph, then z is going to be forwards and backwards. Positive z is going to be forwards, and we'll say negative z, that's going to go backwards. So if I were to say, picture the point 1, 1, 1. If you look forward, that would be one spot to the right of you, one spot above, and then one spot forward. So it'll be off to kind of the corner of where you're at right now. Well, what we're doing here is we are solving again for where these 3 lines are going to intersect. The difference is instead of sticking to just a plain Cartesian plane, just x and y, now, like I said, we're going to do this in 3 dimensions. Let's see, the first step here is to pick a variable to eliminate. I've got x's, y's, and z's, and the way I'm going to do this is look at the coefficients. I've got 2x, 3x, 2x. For y's, I've got 1y, negative 2y, positive 2y. And for z's, I've got positive z, negative 3z, and a negative 1z. Typically, what I would do is I would pick the variable that I've got just one of, if I can. So I see I've got 1y here. That would be a good choice. I've also got 1z here and then negative 1 down here. So I've actually got 2 equations where I've got 1 for a coefficient on a variable. So let's actually eliminate z since I've got 2 equations with that. Next, after you select your variable to eliminate, you have to pick a combination of these equations. I've got 3 equations. We're going to pick just 2 of them. So let's pick A and C since these are already exact opposites. Let's rewrite over here. A is 2x plus y plus z is equal to 3. And C is 2x plus 2y minus z, and this is equal to 6. And since they are already exact opposites, I can just go ahead and subtract. What I've got is 2x. So I'm going to add these together. What I've got is 2x plus 2x. That's going to make 4x. And then y plus 2y. That's going to make 3y. And the whole purpose of adding these together is so that z plus negative z, that's going to go to 0. And this is equal to 3 plus 6 is 9. I've created a new equation, so I'm going to give it a new label. I've got equation A here, B here, C here. Let's call this equation D. Then I'm going to do the exact same thing again. I'm going to eliminate z, but it's going to be for a different combination of equations. I've already done A and C together, so let's do A and B together now. If I did A and B, eliminating z, I would need to match this 3. So I'm going to multiply A by 3 in order to make this 3z. So that'll be 3A here, and then B. Okay, 3a means everything in a multiplied by 3. So that's going to make 6x plus 3y plus 3z. This is equal to 9. And then b is exactly as it is already. So 3x minus 2y minus 3z equals 17. All right, I am eliminating the z. I've got exact opposites, plus 3z here, minus 3z here. Opposites, I'm going to add. When I add these together, I'll get 6 plus 3 makes 9x. 3 plus negative 2, so I've got plus 1y. This is equal to, because the z's are going to cancel with each other, 9 plus 17 is going to make 26. And this is a new equation. I've got equations A, B, C, and now D. Let's call this one E. All right, what I've done is create equations D and E. Let me highlight these. Ignore everything else we see here except for the equations that we just found. D is 4x plus 3y equals 9. E is 9x plus y equals 26. Well, this looks just like the problems that we did in the earlier sections. A system of equations with two variables. You could solve this using substitution or elimination if it were just equations D and E. And so that's kind of the purpose of doing this eliminate one variable with two different combinations of my A, B, and C, is to create a problem that you know how to solve already. If I've got equation D is 4x plus 3y equals 9, and equation E is 9x plus y equals 26, then I can solve this by multiplying E by 3 and matching up 3y with 3y. So let's do that over here. D is 4x plus 3y equals 9, and we'll do 3 times E. So that means 3 times everything in this equation. 9 times 3 is going to be 27x. Plus 3 times y will make 3y. And then 26 times 3, that's going to make 78. Since they're the same sign, plus 3y here, plus 3y here, I'm going to subtract. Same sign, subtract, opposites add. So what's that give me? 4x minus 27x. 4 minus 27 is negative 23. So this is negative 23x is equal to 9 minus 78 is negative 69. And if you want, you can call this, equation F if you'd like. You don't really have to, because at this point, we can just subtract or divide by negative 23 here to solve for x. Okay, x equals, I'll have negative 69 divided by negative 23, x equals positive 3. All right, let's highlight that in green. That is a solution of ours. Are we done? No. We still need to find y and z. So once you find your first variable, x equals 3, what you're going to do is you're going to take a step back. Where did this come from? Well, that came from equations D and E. So you're going to take a step back to either D or E, doesn't matter, your choice, and you're going to plug in x equals 3. So if I were to do that with equation D, that would be 4x plus 3y equals 9. Plugging in x equals 3, this is 4 times 3 plus 3y equals 9. So this is 12 plus 3y equals 9. Let's subtract 12 from both sides. So we'll get 3y equals 9 minus 12 is negative 3. And then we can divide both sides by 3. So that's going to make y equals negative 3 divided by 3 is going to be negative 1. Lastly, I've got to solve for z. So I've got x, I've got y. I found y by taking a step back to d and e. I'm going to take one further step back to my original a, b, and c. And I'm going to pick one of these and plug in x equals 3 and y equals -1. So let's do equation A. Let's do that right here. A is 2x plus y plus z equals 3. And I now know that x is 3, so this will be 2 times 3. And then plus y is -1 plus z equals 3. So this will be 6 minus 1 plus z equals 3. 5 plus z equals 3. And then subtracting 5 from both sides. This will give me z is equal to 3 minus 5 is -2. So x equals 3, y equals -1, z equals -2. In a three-dimensional space here, there is going to be an intersection, and that intersection is going to take place at 3, -1, -2.